Hello everybody and welcome back. Root Beer here, and we're going to be finishing off our 2011 Fermat paper in this video. That's right, it's time for question number 5. Hopefully you've given it a little bit of a try. I'm seeing right now it's definitely going to be a 3D geometry question. The picture sort of hits you over the head with that, but what have we actually got here? A pyramid has a square base with side length 20, a right circular cylinder. Must be my perspective because it kind of looks like a slanty cylinder, but that's okay. They're telling me it's right circular, which means that the face here is perpendicular to the height, so the circular face. Anyways, a right circular cylinder has a diameter of 10 and a length of 10. Yes, they mean the height, but it's sitting on its side, so that makes sense. The cylinder is lying on its side, I just said that, completely inside the pyramid. Okay. The central axis of the cylinder, going through there, lies parallel to and directly above the diagonal of the pyramid's base. Okay. The midpoint of the central axis, so the midpoint of the whole cylinder itself, lies directly above the center of the square base. So it's put on its side, and then it's sort of centered along this diagonal on the square base. Okay, so I sort of understand the relationship here. The smallest possible height of the pyramid is closest to. So we know the base, 20 by 20, but we don't have a height here. So that's going to be our challenge. How can we figure out the smallest height? And it's got to satisfy all these conditions. Now, most of them are just length conditions, not a problem. But they did say the cylinder lies completely inside the pyramid. So if we sort of imagine the cylinder lying there, the pyramid, as the height of the pyramid shrinks, the sides are sort of sloping in more and more and more, and eventually they're going to start hitting the cylinder. We don't want the height to decrease so much that the sides are actually passing through parts of the cylinder, because then some of the cylinder is going to lie outside. So that's our challenge here. Now, it's a 3D geometry question. I find usually the best approach for a 3D geometry question is to start looking at two-dimensional sort of snapshots. So look at it from the top down, look at it from a side. I'm especially thinking maybe we should look at it along the diagonal of the base, just because they make such a fuss about that. So let's get drawing some pictures here. Now, the smallest the height can be is the smallest value, h, we can have where the sides are just touching some part of the cylinder, and that's the smallest h we can get. Because to get it any smaller, then the side of the pyramid might actually be passing through, and then some of the cylinder would be outside the pyramid. Okay. So what can we do? Well, let's look at it top down. So top down, we've got this diagonal here. In fact, we've got another diagonal here, and this also quite nicely, if my picture was a bit more centered, gives us the center, the exact height of the pyramid. These are sort of the sides there, if we want to imagine them. And then the cylinder lies along this diagonal. And the cylinder, as viewed from above, is just going to look like a rectangle. A rectangle, and with the line passing through its center is going to coincide with this diagonal that we've got here. So what can we say here? Well, I know that the length of the cylinder is 10. I also know the diameter is 10, and so if I imagine these sort of radii, here I got 5 on either side. I don't know how helpful that'll be. But we also can figure out the full diagonal is, use a little Pythagoras, you'll have 20 root 2. So that's the total distance. Now 10 of it lies underneath the cylinder, and so that leaves 20 root 2 minus 10 over 2 on either side. Of course, we can rewrite that as 10 root 2 minus 5. Okay. So now I know how far the cylinder is sort of away from the corner. That's interesting. Now, if a side is going to hit the cylinder, if one of these triangular sides is touching the cylinder, where is that going to occur? Well, let's draw another picture looking at it, sort of the pyramid right on. Just trying to understand the spatial relationship. Where might I expect the pyramid to hit the cylinder? So if I imagine the cylinder, it's going to sit sort of about here, and it's just going to sort of look like a circle. I guess it could be heading backwards if we wanted to add some perspective, but I'm no artist here. But if we looked at it head on, does the side of the triangular side of the pyramid, is it going to end up resting on top of the cylinder? Or if I look at it from a different side, pyramid cylinder is sort of like this, heading back this way. Or is another side going to, is another part of the side going to hit the cylinder? And I guess by symmetry would also hit over here. So which things are closer to the cylinder? That's, I think, going to be the main challenge. Is can we figure out where the side should hit the cylinder? If I had some props, this might help out. I don't really have... Most of my geometric stuff are just like Rubik's Cubes, and I don't have a cylinder-based Rubik's Cube, so I definitely can't think sort of hold something and reason my way through it. So I guess I'm just going to have to explore this purely with the math, which I'm fine with, I guess. So, where would I necessarily hit? Well, it might be useful to know if I'm going to hit, say, at this spot over here on the cylinder, it might be useful to figure out how high that is. I guess we already have used an H, so call it K maybe. Oops, lost my whole cylinder. So it might be useful to know K's height. If we had an intersection point. And then what could we do? So suppose we intersect here. How can I actually find out where this is Oh, now that's interesting. So, just imagining, if we imagine my pyramid here, I'm dropping the height off to the side, I can get a nice little, the slopes of these triangular sides is determined h over 10. Right? Because it's 10 to get into the side here, because it's side like the 20, and h is this unknown height. So this will have the same sort of slope, h over 10, as this point would to the side that touches it if I knew this height k. So, I feel like we're going to do some sort of messed up coordinate system. Also, just based on instinct, I think there might be a 3, 4, 5 triangle in my future just because I see a 5 there. Okay. So let's say, would I necessarily, if this side touches the cylinder, if it hits the cylinder, would it necessarily have to hit here first? Yes, because if it's going to hit anywhere along the cylinder, suppose it hits here. Well, this part here is just a little further back, but it's the same height above the ground as K. But you'd have a bigger sort of distance from the side S as opposed to T. And so automatically, T being smaller, this is going to be a bigger slope, and so you would have stopped earlier. Okay, that makes sense to me. And hopefully it makes sense to you, otherwise why am I even doing this? Okay, for fun, if you're curious. I like doing these questions. Okay, now, suppose on my cylinder, on the face, we've got this point here. And how do I want to talk about this point? Let's say it's distance r over sort of the perpendicular height thing here. Now we know the radius here is 5. So we get 5, we get 5r. So what would be the height of this point off the ground? What would be this value that I've been calling k in terms of this r here? Well, it would be 5 plus the square root of 5 squared, so 25, minus r squared. Right, because that's going to be this distance here. And then we add on this 5 here. Okay, so in terms of r, that's what we've got. So if I go back to my top-down picture, if my side hits here, that's a distance r off of the diagonal, height of k. Now, based on this r, can I figure out this distance to the side? Because then I can do this k over s and figure out the ratio. And then I can start trying to, based on various choices of r, try to minimize what h should be. That's sort of the plan. Okay? So if I zoom in on sort of this area here, now it's the diagonal of a square base, so we've got a 45 here and a 45 here. The distance off from the center that we hit is r. Nice little right angle here. This distance. Oh, if I were to drop this down here, we know that this is 10 root 2 minus 5. So this length here would be that divided by root 2. So that would be 10 minus 5 over root 2. And then we've got this distance here. Again, this will be a 45, so this will be a 45 in here. And so the distance over we go is r root 2. And so this distance here will be the full 10 minus 5 root 2 minus the r over root 2 up here. So 10 minus 5 over root 2 minus r over root 2. So that's the distance my hypothetical intersection point is. Now this is starting to get, first of all, it's starting to actually come together. But this is also seeming a little hard. So I feel like I may have, and I do this a lot with 3D geometry problems because I have trouble visualizing them, I may have missed that obviously the intersection point should be over here or something like that. And if I did, then I'm just making this a little harder on myself, but that's because I'm not good at visualizing these things without props. But I'm still managing to get it, and if it turns out that, for example, the side of the pyramid it's going to touch only at the very top part of the cylinder, then r is going to be equal to 0, and we won't have to worry about this. Okay? But the ratio, so the slope from this intersection point, might call it capital R. So the slope of r to the slope of this right here, which should then be the side, slope of the side, in terms of r, must be, what was that height? 5 plus root 25 minus r squared, that was the height, divided by 10 minus 5 over root 2 minus r over root 2. And that's a whole lot of confusing for me. So if I wanted to make this as big as possible, what would I do? Well, I'm not entirely sure. Let's get some sample r values. If r were 0, what sort of slope am I looking at? Well, it'll be 10 over 10 minus 5 root 2. I'm just going to grab my calculator so I can do this fairly easy. 10 divided by 10 minus 5 divided by square root of 2. That's about 1.546 something or other. Okay. What else could I? Well, let's just try 3 and 4, because those will be nice integers up here at least. So 3 squared would be 9, so we'll have a 9 on top. For 4, we'll have an 8 on top, divided by 10 minus 5 over root 2 minus 3 over root, so 10 minus 8 over root 2. And then it would be divided by 10 minus 9 over root 2. And numerically, what are these? Is the top contributing more than the bottom? That sort of a thing. So 9 divided by 10 minus 8 divided by square root of 2. So that's a little bit bigger. 2.07223. So that's definitely sort of in the lead. Remember, whatever the largest slope is, we're going to have to multiply that by 10, because we also want the slope to be h over 10, where h is the height that we're trying, the minimum height that we're trying to find. So right now, I would guess 20.7. Do we have an answer close to that? Well, there's 21.7, 21.9, but again, this might not be the max. We could get, if I did 5, it would be 5 on top, and then 10 minus 10 over root 2. So I've got 2 more things I want to particularly check out. None of them, I think, is necessarily going to be the answer, but I'm just trying to understand the question, or the scenario that I've got myself into. So with 4, I get 2.200, so now we're up into the 22s. At least. Now what happens with 5? So 5 over 10 minus 10 divided by square root of 2. So now we're down to 1.7071. So definitely, just based on me trying a couple values, we're looking at h being at least 22. So that blows the 21.7 and the 21.9 I saw out of the water. What else could we possibly be looking at? Well, actually, that sort of forces it to be B. Assuming all my math is right, there's probably going to be a nice little sweet spot where you can get a little bit higher, maybe somewhere between 3 and 4, or maybe somewhere just a little bit after 4. But definitely at this point, I would say, yep, B is going to be the answer. But I want to be a little more precise if I can. So I'm going to say answer is B. I'm going to keep doing a little bit of work, though. So if you just want to know the answer and just wanted to see a way to do it, there you go. I sort of process of elimination my way out of this. If one of the other possible answers had been something like 23, I'd still have to keep going. But since I hit the highest given value, and I know it can only ever be even higher, I sort of have to have my answer be B. So we'll say definitely it's going to be B at this point, but can we get higher? And if we can, what's the value? 22, and then these two zeros here. That's nice, but their answer at 22.1 makes me think I can do a little bit better. So let's investigate this a bit more. 10 minus, what was it? We'll say 5 plus r over root 2, and that's going to be h over 10. Let's multiply both sides by 10, I guess. I'll say 50 plus 10. I don't like the square root in here. That's what's causing me problems. We'll also have 10h here minus 5 plus r over root 2h. Now, I don't think this is the right approach, because all I want to do is sort of maximize this expression here. We'll put 5 plus. This could technically be written with difference of squares as 5 plus r, 5 minus r. The only reason I do that is I've got a 5 plus r down here. And 10 is 5 plus r plus 5 minus r. Coincidence? I think so, but anyway, I can't think of a decent way to maximize this, unfortunately. I mean, I can think of ways to do it, like calculus, but you definitely don't need calculus on this sort of a math contest. So now I have to ask myself, is it even possible at this point? Did I do the question, I mean, not wrong, because I'm fairly confident in my B answer, and I'm also confident in the steps I took, but I'm not getting a nice single, yep, H has got to be at least this sort of value. I sincerely doubt they wanted us to do it by process of elimination. So is there another setup, is there another geometry that I could be going for? Did I look at, maybe you got to have just the right side view or something like that, and you can see it really quickly. I'm not entirely sure yet. So, do I want to stick with this and try and maximize it? Do I want to say I give up, or do I want to try and do something a little different, try and approach the problem in a different way? I'm really happy with the geometry I did. This sort of minimum slope idea, getting the lower bounds and stuff like that. Not a bad way to do it, but I just sort of meant to fiddle around with my calculator, and it's not a nice expression to do 5 plus that and 10 minus that. Well, would squaring it do anything? Because if the square is maximized, then the square root is maximized as well. Would that do anything about this square root that I'm finding pesky? I don't think that would necessarily help. So, yeah, I don't. All right, well, I'm not saying I'm giving up. I'm not going to end the video here, but I'm definitely thinking that maximizing this is sort of beyond grade 11 level. So what I'm going to do is I'm going to go back to the original problem, see if I can find a more exact way to find this minimum height. Now, something I didn't use, despite the fact that we've got cylinder with the circles there is I didn't try to find tangent lines because I didn't quite know how to set tangent lines for this up. Nor am I still convinced I can, but I'm gonna give that a try. So, all right, let's go back to this top-down view. But once again, I'm happy that I got the answer. B is the answer, but I have the feeling there's probably just a more precise way to do it. So again, my reasoning still stays the same. If this side here is going to touch, then the first place it'll have to touch is on this circle. But what would that look like? I mean, it's almost as though cutting across here, we'd get sort of a tangent line. I'm not visualizing the side itself, I'm visualizing sort of a portion of the side. This is a weird idea. Because I have to remember that this triangle here is sort of like a sheet of paper. This specific tangent line that's coming in and touching is part of that sheet of paper. It's not the side view. It's sort of embedded in the sheet of paper. It's not me looking at the side of the sheet of paper. Again, we can do sort of this based on R stuff. We get a height here, 5 plus square root 25 minus R squared. And yeah, but how is this going to... If I draw sort of front view again, sort of a tangent line, it actually ends up down about here somewhere. Also, we should probably draw this a bit more centered, because it does line up quite nicely with the center of my cylinder. So from the side, we almost get that's sort of what it looks like. A little bit. I think it would have to be a bit stretch here. I think that's sort of what this looks like if I were down at ground level. Now, I think this distance would be a little easier to find because I already know it's got to be the same thanks to this 45 degree. It's got to be the 10 root 2 minus 5. I guess that's that distance, 10 minus 5 root 2. And points of tangency are perpendicular when you connect them up by radii. So that's definitely a thing. And this distance would then be 5. So I would make this distance 5. And using, again, some circle geometry, then this must be 10 minus 5 root 2 as well. And I thought I had something there for a moment. So I think that should definitely be true. The distance from the tangent. So if we imagine this side hitting tangently, get this 10 minus 5 root 2 here in the same plane as the cylinder's top. But I'm not seeing where to go from that, how that might even tell me what R is. Could probably bust out some trigonometry and do this. Drop a perpendicular down there, so it'd be that minus R, and then we can work out the height, I think. So 10 root 2 minus 5 squared minus 10 root 2 minus 5 minus R squared. And we should be able to get the height there. I think I called it K earlier. I'm going to call this Y. So y minus R squared. Y squared minus, it'll be Y squared minus 2RY plus R squared. And that'll be 2RY minus R squared has got to be equal to K squared. Fine. But this expression here is K. We got this down here. We want to maximize, and we're maximizing K squared and 10 minus 5 plus R over root 2 squared. Figuring out the R that maximizes that would also work, right? So 2R, 10 root 2 minus 5 minus R squared. Now, I feel like I'm falling. I feel like this isn't going to help. I should go back a step. I feel like I'm jumping to the maximizing a little too quickly. So let's rewind for a moment. So I'm going to drop that there. I can figure out this length. That doesn't particularly help me. This angle here and this angle should add up to 90. This angle here, so this R here is with 180 minus 2 of the x's. So that would be 2 of the dots. So this angle is the same as this angle. So we got a nice little similar triangle. So we got this triangle here is similar to this triangle here. So 5 is to R what K is to 10 root 2 minus 5. And that R would maximize, maximize the height that we want. So just ignore all that. 5 over R is the same as 10 root 2 minus 5 over K. But we do have another expression for K. It's 5 plus 25 minus R squared, although I hesitate to bring that back in. Now if I multiply both sides, we cross multiply here, we'll get 25 plus 5 square root 25 minus r squared is equal to 10 root 2r minus 5r. Bring the 25 over. Square both sides, we'll get 25 times 25 minus r squared. Should be something. Definitely a quadratic that we could probably solve for. I call this YR again. YR minus 25, and I want to square that, so it'll be plus 625 y squared r squared minus 50yr. In this case, y is 10 root 2 minus 5. Over here, we'll get 625 minus 25 r squared. So I'll get rid of the 625s. That always makes me happy there. And then we'll get y squared plus 25 times r squared. So all I'm doing is bringing this over to this side. Minus 50 yr is 0. Divide both sides by r. We'll get r is 50y over y squared plus 25. All right, that seems to make me happy. And then I know what y is. So I should be able to plug in on my calculator and get what my new geometric approach tells me should be the maximum r that we should be working with. I think. I hope. Anyways, it was 10 root 2, so we'll get... What the heck? We're going to be rounding anyway, so I'm just going to, on my calculator, 10 root 2 minus 5. So y is about 9.1421. So multiply that by 50. Divide by 9.1421 times 9.1421 plus 25. And the value of r we want is about 4.209, which I guess you could then quickly use to maximize this height here that we want. So about 4.209. 5 plus square root 25 minus, let's say 4.2 squared is about 7.7. 7.7129. And then divide by 10 minus 5 plus 4.2, just to make our lives a little easier, square root 2. So divide by 3.4946. So 7.7129 divided by 3.4946 is about 2.207. A little bit higher. And then, of course, remember you multiply by 10 to get the smallest h can be, and that's far clearer that it's about 22.1. So now I have more exact reason to believe B is the answer. But I still got B is the answer, even though this has taken, 15 extra minutes? I don't actually know. I should probably have a timer around here. But there we go. So an interesting little 3D geometry question. It's a little different than the norm because I never quite found a 2D picture that I was quite happy with. I really like the top down. I think that's what really helped me get my initial result there. And then trying to bring tangents into it because we got circles gave me my exact R. So probably a combo of both methods would get you your answer, although it certainly took me a little while to work it out. There we go. So that's our 2011. If you're looking for more Fermats, feel free to browse the channel. I think if you're looking for something a little easier, Pascal, Cayley from 2011 are both up. But whatever you end up doing, keep enjoying math, and I'll see you for more math in a future video.